Alright, so in this video we're going to go ahead and evaluate some limits. In class we talked about the two things that we should be doing. The first thing we saw is that we can just simply plug in and evaluate a limit, and then we saw that sometimes we may get 0 over 0, and when we get this form here we might need to factor and then plug in and reevaluate. So let's go ahead and look at a few examples here. So here for part A, I'm asking you to find the limit as x approaches 2 of 3x plus 4. This here is a pretty straightforward limit. We can simply just substitute 2 into our x variable here. So we would have 3 times 2 plus 4, and then 3 times 2 is 6, plus 4 we get 10. So we could say that the limit as x gets closer to 2 of the function 3x plus 4. In this case it's equal to 10. Going on to part B, we can again do the same exact thing here. So I would simply just substitute the value of x equals negative 1 into our variable here, and I'd simply just have 2 times negative 1 plus 4 all divided by negative 1 plus 2, and let's see what I get. 2 times negative 1, that's going to be negative 2, plus 4, that's going to give me a positive 2, and then negative 1 plus 2, that's just a positive 1, and we know that 2 divided by 1 is simply just 2. So here the limit as x approaches negative 1 of this function right here is just equal to 2. So let's look at part C, and let's again just practice and do the exact same thing. So if I substitute here, I'm going to have 2 times negative 2 plus 4 all over, let's see, negative 2 minus 2, and I'm going to have 2 times negative 2, that's going to be a negative 4, so on the top I'm going to have negative 4 plus 4 over negative 2 take away 2, that is also a negative 4. In the numerator, negative 4 plus 4 is 0. Negative 4 remains the same. 0 divided by negative 4, that's just equal to 0. Let's do another example. I don't have it here, but let me go ahead and write one out. Let me just create some room here. So let's add this one here, part D. So the limit as x approaches, let's say with 2, let's go with 2x, let's go minus 4, and let's go with x minus 2 in the denominator. So again, we plug in, so we're going to have 2 times 2 minus 4 all divided by, if I substitute again the denominator, the x value, so 2 minus 2, 2 times 2 is 4, 4 minus 4 is 0, and then 2 take away 2 is also 0. So here's where we get that 0 over 0. So we have to go back to this limit here and go ahead and simplify this using some algebra, and then we can plug back in once we've done that and then reevaluate. So let's go ahead and do that here. So this problem right here, I can rewrite it as the limit as x approaches 2. And what I'm going to do is look at the numerator. I have a 2x minus 4. One thing that comes to mind is that they both have a 2 in common. So I can go ahead and factor out of 2. And if I factor out of 2, I'm going to be left with, let's see, x minus 2. And you can always just check your work. 2 times x is 2x. 2 times a negative 2 is this negative 4 here, so that holds out. And in the denominator, I'm just going to leave that alone. I have an x minus 2. And this here evaluates, so we can look at the x minus 2 in the numerator and the x minus 2 in the denominator, and we can go ahead and reduce those. So that'll reduce right there, leaving me with the problem. So now our problem becomes the limit as x approaches 2 of just a constant 2. And what is the limit of a constant? Well, it's just that constant, so we say that the limit here is just 2.